Algebra 1, Lesson 52, Part A, is more about adding rational expressions that do not have common denominators. We've done some of these before, just these are slightly different. They're slightly different denominators than we had in the previous one. The beginning of this in your notes is just reminding you of that fundamental theorem of rational expressions, which is about getting common denominators. And I'm not going to reread that right now, but it's right there in your notes for you, so you don't have to look it up in the previous lesson. So we're just going to do a bunch of these. And in the first one here, we have a over x plus b over x plus y. And we need to have fractions that have the same denominator before we can add their numerators. That plus means this is not xy. Your common denominator cannot be xy. X plus y is going to have to be part of the denominator, though. Anytime any of your denominators, when you're adding or subtracting fractions, has a sum in it like this, that whole sum will be a factor of the common denominator. Basically, we're going to take x plus y over x plus y times this first fraction, and then also x over x times the second one. So our common denominator is x times x plus y. And I'm going to go ahead and put that in parentheses also, because that entire sum is being multiplied by that x. Okay, now we see they both have the same denominator, and we just now multiply here that a times the x, and then put the plus, and then a times the y, and then plus, because we're adding the numerators, bx, and that whole numerator is over the common denominator of x times x plus y. So it's very similar to the ones we've done before, just now the denominators are slightly more complicated. Okay, so in the next one factor of our common denominator is going to be an x, and the other factor is a plus b. So we need x over x times this one, and a plus b over a plus b times this one. Each denominator now is x times a plus b. Okay, common denominators, and now we can add the numerators, but we also have to distribute. Here's x times 4x, that is 4x squared, and then plus x times a, I'm going to write it as ax, plus, and then we have c times a, which I'm going to write ac, plus c times b. I'm just putting the variables in alphabetical order. It's easier to check for like terms. Then we have on the denominator again is x times a plus b. There aren't any like terms, so that's it. Forgot to circle the top one. Okay, next one. This one is very similar, it just has 3 terms. And remember, when there's something not written as a fraction, we can put that over 1. There are no sums in the denominators of this one. Basically, our common denominator is just going to be mx. I already have an x in this denominator. We need to multiply it times m, and again, the rule up here at the top of your page is whatever you multiply times the denominator, you must also multiply times the numerator. I'll put that sum in parentheses. And then here I didn't really leave space, but we need x over x times that middle one. And this last one only has 1 in the denominator, so we need mx. And then distribute this m. am plus bm. Next fraction we have in the numerator c times x, so cx. And then the last term is dmx, and that is all over the common denominator of mx, and there are no like terms. That's all there is to that one. Okay, now there's one more example on the next page here. Let's let that refocus. Okay, and on this one, I'll smudge on my paper. Our common denominator is going to be k times b plus c. And maybe instead of squishing things in like I did on the last one, I'll write this nice and neat. We have a over b plus c, and we're taking that times k over k, minus, I'm going to write that x over 1, and this needs both of these factors. So k times b plus c, k times b plus c, and then plus, okay, this has the k, it needs the b plus c, which we're multiplying times this d plus m over k. I've written all the sums in parentheses because I'm getting ready to multiply. Okay, so in the numerator for the first term we just have a k, then we need a minus, and now in parentheses I'm going to put what I get when I take xk times b plus c. Alright, so, and again I'm going to alphabetize my variables. So I have bkx, and then also plus ckx. Alright, so that's from the numerator of the second fraction here. Then we have a plus, and now I'm foiling this. Here's a binomial times another binomial. B times d plus b times m plus c times d plus c times m. That whole thing is over our denominator, which is k times b plus c. Okay, now, just quick check for any like terms. I don't think there are going to be any. No. All right, so the reason I placed this one in parentheses and not this one here on the end is because this one was a plus, this had a minus in front of it, and I know both of these signs are going to have to change. Whenever there's a minus before a polynomial like that, all the signs inside here in this polynomial are getting changed, and I didn't want to forget that, so I put them in parentheses. And now I'm basically going to be distributing that -1 that's in front of here. So last step, ak minus bkx minus, because again it's basically a -1 times this also, because we're distributing it, minus ckx plus bd plus bm plus cd plus cm, all over our common denominator. And you don't have to distribute the denominator. We always do the numerator though to see if we have like terms to add. And there we are. That is the end of part A. Part B is called overall average, and first we need to talk about why it's important to make sure we're doing these carefully. And I want to give you an example up here of a couple sets of numbers, and we're going to have one set that's just 1, 2, and 3, and the other one is going to be just 4 through 10. 4, 5, 6, 7, 8, 9, 10. And we're going to find the mean of this set and the mean of that set. Okay? So, the mean is 1 plus 2 plus 3 all over 3, because there are 3 of them. And that is 6 divided by 3, so that's 2. Okay? For these, the mean of the second set of numbers, okay, so we add up all of them, let's see, 4, 5, 6, 7, 8, 9, 10. Okay, I got them. So we have 13 plus 13 plus 13. Okay, 13 times 3 is 39 plus 10. So that's 49 over 1, 2, 3, 4, 5, 6, 7. So the mean of that group is 7. Now, what I want to point out is, when we're doing overall average, if you're given two groups and you know their averages, you can't just find the average of the averages. Okay, and I should have left a little more room here for this. Basically, if we were finding the mean of these two numbers, we add them and divide by 2, right? And that would be 9 divided by 2, which is 4 1/2. But look what happens if we do the mean, okay, of the numbers 1 through 10. Okay, if we want to find the mean of all of them, that'd be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 divided by 10 because there are 10 of them. This is, let's see, 10, 20, 30, 40, 55. 55 divided by 10 is 5.5. But if I do the average of the averages, or the mean of the means, then I'm getting 4.5, which obviously does not equal 5.5. Okay, so it's very important to remember that and do this the way I'm about to show you. When you're doing the overall average, you need to take the total of all of the numbers, okay, the sum of all the numbers divided by the total number of numbers. Okay, you would need to do it this way, adding all of them together as one group and then dividing by how many there are total. All right, so look at example 5. The average of the first 90 numbers was 4. The average of the next 10 numbers was 6. Okay, we already know we can't just do 4 plus 6 and divide by 2. But they're not telling me what the total was for either of those groups. But here's what I know. The way we got this average, okay, so average of this first group, all right, first group. The average, or the mean, that's what they mean here when they're saying average, the mean was the total of that set divided by how many there were. Well, it was 90, right? And the mean was 4, so that means, okay, so 4 equals the total divided by 90. So I could multiply both sides by 90, and that means the total, I don't know what all the individual numbers were, but they all added up to 360. See, so I can take the mean times how many numbers there were, and that gives me what they added up to. So to do these, what I'm going to do is take 4 times 90 plus, okay, the average of the next 10 numbers was 6, so 6 times 10, I'm taking the average times how many there were, and that gives me the total from that group. So if I add the total from the first group to the total from the second group, that's the sum of all of the numbers. And I divide by the total number of numbers. Well, there were 90 here and 10 more there. That's 100. And now I use the order of operations to simplify this. So, oh, and I should write overall average. Okay, so this is 360 plus 60 divided by 100. That's 420 divided by 100, 4.2. Or I could have just kept reducing the fraction, but a decimal is fine. Okay, that is how we do these. And that's the end of the notes. Have fun.